you, Luis. Okay, so I need to share my screen. Just bear with me one moment. I'm sharing my screen. Okay. Can everyone see my screen?
Yes.
Okay, excellent. Okay. Well, good morning, everyone, and welcome to our presentation on photometry, from water to wine, from research to industries. My name is Giovanna Esposito, and I am the sales manager for the lab solution vertical for Xylem Analytics for the region of Latin America. Our agenda today, in our agenda, we will introduce you to Xylem and VTV, followed by the presentation on photometry by Mrs. Susanne Goller, the Senior Product Manager for Photometry and Turbidity. So who is Xylem? Xylem is a global water technology leader who works with customers to solve the most critical water and resource challenges. Xylem has more than 1,700 colleagues around the world with diverse water expertise, along with a presence and operation in 7 continents. Our products are sold in over 150 countries. We move, measure, analyze, and treat water. We partner with customers to solve the most important water challenges. Our solutions span through the entire water cycle. We bring together advanced technologies, application expertise, and smart, sustainable solutions. Measurement and control is a segment of Xylem with a revenue of approximately $1.4 million. VTV is a Xylem brand and part of the measurement and control solution segment, located in Walheim, Germany. Xylem Analytics' largest location with over 400 employees. VTV was founded in 1945, moved from Wesselbrunn to Walheim in 1954. In 1965, VTV came out with the first dissolved oxygen meter. In 1990, VTV started with the online measurement technology. In 2003, VTV was acquired by Nova Analytics. In 2010, Nova Analytics was acquired by ITT Technologies. In 2011, Xylem emerged from the spin-off of the ITT Fluid Division of ITT Corporation. In 2013, Ebro, another Xylem brand, was integrated and moved to Walheim, to Walheim's location. And in 2016, 4 other brands were integrated in this location. And so this location became Xylem Analytics Germany. The VTV Xylem product portfolio includes handheld meters and sensors, desktop devices and sensors, photometry, and biochemical oxygen demand devices. On the process side, the portfolio includes the IQ SensorNet, analyzer for river monitoring, and process control, as well as the Multiline 1000 for the monitoring of clean drinking water. This is just an overview, an image of the new facility of Xylem Analytics in Germany. And now it is with pleasure to introduce to you Mrs. Susanne Goller. Mrs. Goller is the Senior Product Manager for Photometry and Turbidity. She's a biologist with more than 20 years of experience in product management and OEM partnerships for photometry and turbidity. She has an extensive background in the field of research and has held various roles in informational technology, including business development in the field of software. Please welcome Mrs. Susanne Goller. And with this introduction, I will now turn the meeting and controls over to you, Susanne.
Thank you very much, Giovanna. And I want to welcome the audience from my side as well. And looking for almost an hour to photometry, I just share my screen, and I'm happy if you can give me a feedback if you see my screen perfectly. That would be fine.
Yes, we can see the screen, Susanne.
You can? Okay, but I just need to start the big one. So you should have the big panel right now. So I want to introduce today a little bit of the VTV, so WTW photometry. And we talk about routine instruments. We talk about the class up to 4 nanometer instruments, which can be used in water, drinking water, wastewater, as well as beverage industries, but also in education and great many other fields. We will look at it a little bit later. Jesus, you have already said which is our agenda today, so I will skip that, and this leaves me at least to our, we are in photometry, and I want just to pick up a little bit the general handling and safety needs. All of us go to customers and we have to deal with environmental testing. We have to deal with wastewater treatment plants. So for us, as well as for our customers and you as the customers, it's very important that we have all of us the personal security accessories. I know that you all know this, but it's just a little reminder. Sometimes we are so fast in our routine that it can be good if we have to go to different sites to do that. So basically, we want to have a look, what is photometry like before we start with individual instruments and routine test kits, for example. So photometry means, comes from the Greek word phos, which means light, and the photometry is a measurement method to measure or analyze water solutions by means of a light source. And light, as you all know, is a spectra of electromagnetic waves, which can be divided into different ranges of the light. So we have the UV section here between 190 to about 380 nanometer. Then the visible light, which we all know, like if you look at a rainbow, from 340, 380 nanometer to 780 nanometers. So this is where almost all our routine testing with reagents is taking place. And then we do have the near infrared range, which goes from 780 to 1100. And if you look, this is the VTV range, which we cover with our 2 spectrophotometers. So we have a UV vis meter, which goes up to 1100 nanometer, and also a pure vis instrument, which goes from 340 and reaches also to 1100 nanometer. The near infrared is interesting because we have here no absorbance, and this is where our turbidity correction takes place. You know from the last session eventually that turbidity is not disturbed by color in the near infrared. So what does photometric colorimetric analysis do for standard parameters like ammonia, like phosphate? It means that we make a determination of this parameter, so substance, ions, whatever, by their specific color reaction with known reagent, which can be commercial reagent test kits. And then we measure this absorbance at a specific wavelength. So this is photometry in brief. There can be different lights and different optical systems. The easiest, which is mostly in the field photometers, would be a LED. LED is, the advantage is that it has a very low power consumption, but also the intensity of the light. So the brightness of the light is a little bit smaller. Then we do have tungsten white light, which means the complete visible range. And the wavelengths are obtained by specific high quality filters. A spectrophotometer, and particularly our modern 4 nanometer spectrophotometer, is a xenon flash lamp. So in one lamp, there is UV and vis. This is the high durability, almost or more or less as the lifetime of the instrument, and has the advantage to be much more economic, as then we have the very expensive systems with a separated tungsten white light and deuterium UV lamp. So in combination with this, that is a more expensive cost of ownership. So you have to pay more because these lamps are really more expensive. And then there's optics, which are different. So spectrophotometers like our Photolab 7000 do have a monochromator. So there are for multiple tasks, you can do scans and have the complete wavelength range available. This is many optical systems, but actually they are all built more or less like the same. It can be a reference beam technology, but in fact, we do have a monochromator compartment and then a lamp, and this is going through this compartment to get the individual wavelengths here at the end. A polychromator, if you are working with IQ SensorNet of Xalem Analytics, you know that UV vis sensors, they have a polychromator. A polychromator means that the light is split up in all wavelengths at once. It's not a step by step. It's just getting the wavelengths at one step. And then we do have the filter photometers, which have, as I said, a high interference filter to get the single wavelengths, and they are so precise, still top of the pop, and they are robust at the same time. And finally, the LED lamps directly with some optical filters for a higher accuracy and precision of the measurement results, and it's very easy to handle and also has a very long life. I will turn off my video because we do have a little bit of unstable lines otherwise. So photometric measurement modes are split up into 3 basic measurement modes. It is transmission, so it means just the light before a cuvette is more bright, more intense than after the cuvette, because part of the light will be absorbed in the cuvette. And this is what we call transmission. So it's the ratio between light intensity after and before this this vial, this cuvette. Absorbance is a logarithmic function and means just that the part of the, it describes the light which is in the solution and which is kept by the solution more or less. And concentration measurement will be done by a quantitative analysis in comparison to absorbance and transmission, which was just describing the quality. And now concentration is the opportunity to measure a quantitative amount of a substance, for example, because of the absorbance at a certain wavelength, and this is based on a calibration curve. Now, there is a correlation between transmission, absorbance, and concentration. Here we do have how much light is going through the cell, and that's logarithmic. And much easier, the linear correlation, which means the higher the higher the color, the more light is absorbed, and this is a linear function. So we do have an absorbance in routine measurement up to 3 absorbance units, more or less. And here also we can make a direct correlation to a concentration. How is this done? All of you might have done that already automatically with a modern photometer. I have even done it by manually doing these calibration curves manually and putting them on a piece of paper and then working with that piece of paper. So it means all these calibration curves are stored in a meter today, but how do you get it? You need to know where is the absorbance of my reaction of a routine test kit, for example, ammonia. Then you choose this wavelengths. You choose it, for example, because you do absorbance spectra here of this reaction, and then you know exactly that the peak here is at, for example, 540 or 525 nanometer. This is the wavelengths where you will set up a calibration curve. And the calibration curve is nothing else than that you have the known substance with a standard, and then you make a 10-point calibration and you read the absorbance value. So it's just a qualitative measurement, how much light is trapped in my solution. And then you get this calibration curve here. So you need the wavelengths and the reaction, a known reaction. But the reagent can be a little bit colored. You know it best from COD, which is bright yellow. So this color absorbance must be subtracted, because that would give you a wrong reading. So all programs for routine test kits have already this reagent blank subtracted, and it's just stored with the program of a test kit. Then the sample blank, a sample could be colored. There is no, this is not included. It can be different. There is no common color. And the other thing is usually it's clear, or you have such a small amount of sample that this doesn't play any role. If the sample blank would be bigger, then eventually you get, because of the color, a wrong result as well, because then you couldn't read everything on this particular wavelengths. So with commercial test kits in this small amount, the sample blank usually is not play a big role, and therefore it's not considered in the measurement. Then we do have citation and units. So we would have citation is the, for example, here nitrogen nitrate. And then we have milligram per liter, but it could be also millimole or parts per million. So you can switch that, and therefore there is a calculation factor, because this is just a different measurement. And all these measurement and calculations to get the result in the correct citation and unit are stored already with this program for this particular test kit. And then we do have the slope of the curve in a spectrophotometer. This means here that is just how this curve mathematically, the slope is given. And with this, you could enter, this is called as a factor for calibration curves. And this in any other spectrophotometer, you could enter and get the calibration curve into the meter. Important also for concentration measurement and programs is that the so-called Lambert-Beer-Gesetz, you know it, which means just that the path length, so the size of the cuvette 10, 20, and 50 millimeter plays a role, because the concentration is proportional to this length of the cuvette. And also, if you can use different cuvettes, this is also already stored in these programs. Now, in fact, photometers can do some more measurements, but they are all based on absorbance, more or less. So we had one already, and this would be the spectra. So you can say, please measure the absorbance in a solution from 400 to 800 nanometer, or the whole range, whatever. Kinetics, you know kinetics, it's mostly in enzymatic testing. And this means I read the same solution for a period of time, always at the same wavelengths. The diagram I have posted here is, for example, it's a temperature reaction time on a too cold or a correct lab sample for drinking water. So I have a good, you can see that if the water is too cold, the development of the reaction is slower, and this is done with a kinetic program of a spectrophotometer. And then there is all kind of complex programming which we can do with a spectrophotometer of modern life. And just a simple measure, a simple program would be the wine quality, wine color. So this is an application of a spectrophotometer, and this is color intensity, or also color nuance, which is a quality parameter in wine industry. And so with readings of these different absorbances, there we have the color, the description of the quality of wine. So beverage, this could be juice, this could be whatever soda, sample preparation before, but it could be any kind of beverages where a photometer, for example, does have some tasks and can be measured with according to several parameters beside, for example, color. So the application is already, I already said some of them. So we have waste and drinking water. This can be ponds or on-site, or it can be reservoirs, it can be waterworks, but also it can be a governmental and health and administration who are surveying all these. And there a spectrophotometer is interesting because it has all these analytical quality assurance options, which means we can test and prove our results. So this is something for governmental, but also environmental monitoring programs, for example, biological studies, governmental studies, surface water. We have institutes, education, research, mining, and these are all tasks for parameters like phosphate and iron and manganese and whatever is the application, bromide, iodine. So there are so many parameters which are not all available as a test kit, but this is where this 4 nanometer instrument is as an economic solution, and also in education, multiple places. So more than one place for students is a very good solution. Fish farming more and more coming up, particularly if it's like basic basins or half circulary inland basins. Then we have all the swimming pools, lakes, reservoirs. There is Photoflex, a very good meter, and we do have food and beverage, as I said already. And finally, if you have a process online measurement system, like our IQ SensorNet, also reference measurements must be done with these online measurement systems. Now, routine analysis, we said that already, is a photometer, and we have in routine known parameters. So it's a system of the meter and a commercial test kit. Now, we do have more than 200 pre-programmed commercial test kits for all these standard parameters. Then there is in total 100 parameters and application modes which are supported. Why do we have more programs than we have parameters? Because with one test kit, you cannot measure the whole range of a parameter. So we have several different tests for different measuring ranges. For example, ammonia can be from 0.02 to 8 milligram, or from 5 milligram to whatever higher milligram. So basically, or COD, you know it, it's from 4 to 40 milligram, or from 10 to 150. So this is why we have more programs than we do have parameter supported. And there is application methods. This means multi-step measurements, like, for example, wine color. And all of them do have these settings automatically given, as we have seen it in the basics before. A a very special thing about our meters is that we have an automatic via barcode. This have many other instruments as well, but we have a mode to do it with rectangular cells and round cells in the same meter. I will show that in a minute. And also we do have a cell size detection. So automatically, this means if you put in a 16 millimeter or a 10, a 20 or a 50 millimeter cuvette, automatically the system is switching to the correct measurement range. You remember the size of the cuvette, the length of the cuvette has a role what you can detect, because there is a correlation to the path length, so to the cell size. And this is automatically detected, and therefore also the measurement range can be switched automatically. So this is something very special with our meter, with our spectrophotometers. And the analytical description and test information is either in the packet leaflet or in our analytical handbook for the analytical descriptions. And the measurement range, because we do have different light and the light has more or less intensity, also measurement ranges are different. So a spectrophotometer can have a bigger measuring range than eventually our PhotoFlex portable colorimeter. And since these programs can be programmed, if you have, for example, Analytic does have test kits, or you have your user-defined need in education or institutes, these methods can be programmed and implemented into the meter. And with support of all of us, so Analytic and also we are here in the background if needed, this can be adapted to your special needs. These are the test kits which are available, and this is, for one thing, it is the cell tests with a barcode. So that is the easiest to handle. You just add your sample and eventually add a drop of this and that, and then you can automatically measure it. It's pre-filled tubes and it's the highest quality level. They are manufacturer specific because other manufacturers do have a different length of the cuvette, or they do have a different diameter. So this is why I talk about a system. And from the same, there is a reagent test kit with barcodes. So here we do have a little, like a little dummy of a round cell with the barcode. So we can place this barcode and then measure with 50, 10 or 20 millimeter cells. And we have the very high precision, the same precision with certificates, etc., and also a very economic, but we have a very economic measurement. It's almost as cheap as powder pillows, but the quality and the complete convenience is much bigger, particularly because we have also the barcode. And since we have a 50 millimeter support, we do have a very wide measurement and can even do a trace analysis. So this means very low concentrations. And then there are test kits, which is a cell test without a barcode. So this is very convenient. I just choose the correct program by entering a number or going into a search window with my spectrophotometer. It's also pre-filled tubes. It's just a little bit simpler and therefore mostly a little bit more economic. And then this is ideal. You all know them, the powder pillows, these little sachets where you just have one portion of reagent in these little sachets. They are very economic. They are easy to store, and they are ideal if you go in the field. Because if you go in the field, it can be hot, it can be humid, whatever, and there is no danger to spoil it because you have just this one portion and you can just add this one, and even if you take just what you need, it wouldn't be spoiled by heat or something. Some of the test kits have a little less resolution, but for example, the standard parameters iron, chlorine, they are absolutely good. And here is these two, compared these two, they are almost at the same price level, but they the barcoded ones are really very high in quality level. So they are with a high resolution. Now we have the reagents, and we know that they match a photometer. So what photometer do we have? We have photometers in total, very well proven series. And probably some of you know even the Merck Nova, or has the Merck Nova meter, filter photometers. They are so stable and fantastic over the years that there are much more than 20,000 around. And this technology, measuring barcode with all these cells and automatic test recognition and cell and cuvette recognition, this is coming from this extremely successful photometer. We have brought this technology for the high and simple measurement, high quality but simple measurement, to our spectrophotometers from the Photolab 7000 series. So this means we do have a VIS and a UV VIS meter. And this simplicity of use has been combined to some really new and pioneering measurement, because we allowed that the reagent-free measurement from our online UV VIS sensors has been brought to the measurement of a spectrophotometer. This means we can measure COD, nitrate, and nitrate here without reagents. And then, as you all know, you need to go in the field, or it can be a small and economic bench addition, or whatever is your task. So for example, if you are working in a university, you can go out. There's a little field set, and this is a lab to go. So we have a high precision LED photometer, so a colorimeter. And there is one model which is even a 4-in-1. So you can measure photometry, pH, turbidity, and ORP. I come to it in a second. I call it our Swiss Army knife. With the spectral, you have, as we mentioned already from the optics, all in one and one for all. If you are measuring at 4 nanometers, it can be the routine analysis with all the advantages I have said already. It can be the reagent-free measurement, but also special and multi-step procedures. If you're measuring chlorophyll, I think we have already 10 different programs for chlorophyll, and if you need a different one, you can just program it. We had a customer in Asia Pacific who measured DNA concentration because they had a project about fish investigation, fish monitoring, which kind of fish species were there, and they did an extraction of DNA, and to see if they would have enough for if it's working with the subsequent steps. They measured with our meter the DNA concentration and were very happy that they didn't have to buy another instrument, but could do it with our photometer. Then, as I said, beverage, wine quality, if you have winemakers, if you are a winemaker, but also in research, it's a nice small instrument for protein kinetics enzymes if you work in a research, a service lab, or in education. And there are many, you can make your own big programs. It's all described on screen, but I know this is not too difficult. So whenever it comes to something like that, I'm sure we all will help you to get to a programming which you need. And finally, spectral analysis and kinetics, as I said already. But, and this is important as well, if you are doing for example, environmental, or if you are a service lab who is going to different sites from your customer, or if you are servicing, help to service whatever spas or something, This is a lab to go. This whole meter, there is a field set and you just can take it and go to any place and customers. So that's why we say from water to wine and from research to production. It is really supporting a lot of applications, and maybe it's not, it's a little tiny thing. It is really designed and produced in our Weilheim site, which Joanna has showed you. So this is coming from our own factory and from our research and development department. We had that already, how easy it is to use. So actually, you just need to open this lid, you place your cell, and then you read the result. That's all. So in the concentration mode, for sure, we have the test kits for that. And as I said, we have for round and rectangular cells, the barcode and the automatic switch. So this is really a very advantage. And this we also took from a filter photometer. We have a so-called pulsed lamp. This means when you place the cell, so when you place the cuvette into the meter, then the lamp is switching on. And the advantage is that you do not have the lamp constantly on. And because it has a reference beam, you can just measure very fast, because with the reference beam, it must not be warmed up, for one thing. And at the same time, you are saving a lot of money because you do not have to exchange the lamp constantly. And that's also why with a field monitoring task, you just can have it in your truck and you can go for days, if not even weeks, and measure and store these data or put them to PC, whatever. So it's fast, it is easy because it's fast for low or very high testing volumes. It's easy to use for some, if you do not have to measure so often, but if you are, for example, in a monitoring program, you have really a lot of samples. So both way, it is just supporting high and low volumes. And you have a low cost of ownerships because the lamp, you do not have to change the lamp very often. Well, it's a spectrophotometer, so there is all kind of analytical quality assurance. And as we said, reagents for any need. The reference beam means just that it's an increased precision, that it's very fast, and that we can have together with pulsed lamp a very economic solution. If you do work, and you will do it in your daily life as well, if you have kinetics and cymatics or to run a spectra, then definitely you will warm up the instrument more for a longer time, because there is a PC board inside and you do not want to have a drift of the meter during your measurement. But if you are just with routine, there is the pulse lamp just fine. We do have a very fast data acquisition. This is good for samples which are a little bit more difficult. We have it's a clear display. It's not a touch screen. One of the reasons that it's not a touch screen, we followed a little bit the Windows philosophy, that you have F1, F2, F3, and it's always at the same position and you come to the same menu. And since I said we have a field meter but with a spectrophotometer, which is high precision lab technology, it for outdoors, a robust and easy cleanable keypad is very easy. And as you can see here, the handling benefit means we do have direct access to home and print and store, and you get also a feedback, particularly when you are outdoors. It's at the same time, it has just an intuitive handling. As I said, the Windows function key, you come always to the same function. That's a little bit like that. So it's context related. And as I said, car battery and robust keypad makes it an ideal on-site instrument in the field for environmental monitoring, reference measurements for online sensors, etc. you just need a regular car battery, or you just the regular switch. So there is no special cables, no nothing. So it's very, very simple to take it anywhere. I skipped this because we had that already. I just want to focus one thing. We do have, because we have these automatic cell recognition, our cells in our meters need to have a structure or be a little bit opaque, because our detection system needs any structure to be able to detect. All routine analytical methods, there's updates. You can update the meters via USB stick, for example. There are lot certificates from our suppliers. There is a comprehensive AQA opportunity, from calibration solution to also even filters, liquid filters, holmium filter or glass filter from Helmer, whatever company is available. So there is a lot of meter checks possible. We do have the spectra and kinetic measurements with a big editing function for spectra. So this is, if you are working in universities and if you are in research with your student programs, etc. So this meter does have a very extent opportunity for spectra and kinetics. And as I said, for industries and environmental, we do have a lot of multi-step procedures already stored in the meter. It's 10 programs for chlorophyll, which is, who of you is working in monitoring, you know, you have to extract the sample and the chlorophyll, and then it has to be checked with pH. The pH has to be given in. There is a measurement before and after the I don't get it now, acidification, and this means that you have different wavelengths. So these programs are already stored, but there are many more. Like, for example, we can measure carbon dioxide and free ammonia, like in aquaculture, very interesting parameters, also nitrate. And this means you can enter the pH and then take an ammonia test kit. And with this combination, you can, for example, measure free ammonia. And as I said, whatever you need this can be programmed simply. I just have given here a little example from, for example, everything about saccharose, glucose, fructose. These three are already programmed, because it's depending what test kit company supplier you are using. So it's different, but it can be programmed. And it means that you have at the end, with all these different enzymes, you can finally determine these different sugar types. And the rule of the determination, the principle is simply that we do have a difference of absorbance between the reduced formate of the redox pair in this biological application. So all of you who are in industry and in university or beverage industry, you know, and food production, you know that this is one of the big measurements to be performed. So this can be done with the photometer. And here I come now to a very special thing, which is part of our complete system, which means we have learned it from our online measurement system, IQ SensorNet, and the process sensors. And it is the so-called OPT-RF, so optical reagent-free measurement for COD, NO3, so nitrate and nitrate. I just have to say nitrate is hard to measure because nitrate and nitrate are at the same absorbance range of a photometer. And if there is a lot of nitrate, hardly the nitrate can be seen. It's depending on the sample. And our models are for surface or sewage plant outlets. That's important. With the meter, we cannot measure inlet. You can imagine the inlet is just a heavy broth, let's put it that way, eventual colored, etc. So it's not made for a spectrophotometer in the lab. In the field, we do have this polychromator, so you get all wavelengths just with one stroke. This is not here. We do have a scan. The application where this can be used and tested is sewage plant outlets, surface and river waters, and also for matrix, so-called matrix adjustment of IQ sensor net in the outlet. There are profiles, so you can make settings for different locations because no water is like the other water. If you think about basins, if it's a very huge wastewater treatment plant and you have several basins, you know that it's always a little bit different because you do have different microbiology. So actually, this is what we call matrix. And therefore, we can set up different measurement settings. And we do not have to switch then cuvette. We can, with one and the same sample, measure several parameters. The limitation is it's not working into industrial water because organics do not absorb in UV range, and therefore it will not be detected. And it sounds, I will show you how it works, but if you are using it, there is for sure an implementation period, and this will be supported from Analytic, and Analytic does have the our backup from our specialists in our application department. So here we do have, at the end, you take what you want. This is 4 parameters which you can do, and it's dissolved COD, and it is total COD. You choose simply the method, then you pipette your sample into a quartz cell because we are measuring between 340 200 to 380 nanometer, and then you get a value output. So what's happening in the background is we have algorithms from great many, as an average, from great many sewage plants, which are stored, and then the data are compared more or less. So we have many calibration curves from many real world wastewater treatment plants, and then there is an evaluation taking place from the scan, and then a value is output. And you see a raw value here, which means this is without optimization. But as we said, every environment and any water anywhere is different. It can be optimized at the customer side for your special environment, and then it means just that the precision and accuracy is getting better. What is the advantage? It's cost-free to measure more often because you do not need any chemicals. You can also do a cost-free measurement range check or a cost-free retainer sample check. So it's reducing the overall cost. It's not reducing everything. First, it is not accepted to be a reporting standard method according to regulations. The second is, as I said already, it is always mandatory or recommended that an implementation period to make it best accurate in your environment. And it's because we do not have any chemicals, it's eco-friendly, and you just can throw the sample away as you would do any normal sample. So it's not hazardous also. And it is also a matrix check. All these, and you do not have any digestion time. That's another one. So it's a very short and quick measurement. However, for all these systems, a standard regulation method like a cuvette test is the basic for all these implementation and adjustments to make a little bit of the best accurate method in your environment. So a matrix assessment. And as I said, we have a lab to go, so measuring on-site everywhere. We have only a 4.5 kilogram instrument, which can be put into a field case. It's a standard car battery. We have the pulsed lamp, which means it is hours and days. If you use a track battery, no special cable required. It should be weather protected. And we have, for example, service. If you service drinking water works, if you are servicing, for example, if you have to travel around for smaller sites, if you have some building up of new wastewater plants in rural locations or something, then we have, for example, a customer here in Germany who has built up a van lab or a lab van, whatever we want to call it. And he has his laboratory inside of a little truck and goes around. And for this, he can go for a week. It's ideal for servicing people. It's ideal also if you are working in a governmental program to survey different plants or sites. So actually, it's lab to go in absolute high lab precision. Color measurement is another thing we can offer here. And we have a PC triggered color measurement. So it's usually done as an income control or in sugar industry, brewery, but also if you have wall paint, resins, oil, varnish, all this is always a quality control if it's aging. So if the color is changing and the product is being spoiled. So actually this is where the applications are. And usually color is something, it's an individual subjective perception. So color, no person will see the same color probably. And with a spectrophotometer and a color measurement, according to different methods, it's also, there are different methods available. Here, this is a CEI, a big three-dimensional color measurement. This can be done easily. Now, if someone is doing only quality control with color, there are special instruments. But if you are, for example, a servicing lab, this allows a lot of measurement also according to some standards. And this means it's fulfilling all different ways of, for example, the method yellowness. There is a observer angle. So this is all definitions to have comparable values of color, because a human eye would never be as exact as this method, but there are given definitions which are common in the market. So it's like a program. And then beside the spectrophotometer, I will come to the field colorimeter. So in fact, it is kind of a little benchtop solution because we have like a docking station where you also, because it's connected to power supply, can add a little barcode reader, and our analytical description have barcodes. So actually you can also ease your functionality in the lab, and it has lab precision, but it is a very nice, handy, flexible instrument. So there is field sets available. In total, we have 3 beaters, as I said. So standalone for, I come to it in a minute. So 3 different functionalities, and this can be done with 16 millimeter and 28 millimeter vials. It's a attached chamber for measurement. And also, if you have a field set, we do have even a little bench, which is here placed even in the field case, but you could put it on site. And as you see, it has a lot of little caves, so everything is sturdy, and your samples do not roll around. So actually, you have just your little lab to go. It's also designed from our engineers, and it's also produced at our Weilheim site. And it's available with a docking station, but also with a rechargeable battery for field monitoring as an option. And we can send the data in many different ways up to limbs, and people can even pull data for limbs. So we have a very wide range, particularly if you're in research or you want to have a more economic site instrument in a very administration used environment. So there are some options to fulfill also some regulated measurement modes. So what we do have here is there's 3 instruments and their field set, so it's 6 options in total, which means standalone photometry, as I said, great many programs, all these different reagents you can store with ID number, which means if you are in the field, you can, for example, give a number to each site, and you have a data filter inside where you even can then filter the data according to the different sites, dates, parameters, and make a big output, already selected output to PC or wherever it should go, or print or LIMS, whatever it is. Then the next higher instrument would be, it has the PhotoFlex standard setting of photometry, but then we add a pH and a ORP, so redox measurement. That's, for example, something for aquaculture and fish farming. And because we do have pH or electrochemical pH measurement with temperature compensation, we can measure free ammonia and carbon dioxide by simply just measuring step by step pH, and afterwards with a regular standard kit for ammonium and acid capacity. Then we do have these 2 parameters additionally. The redox measurement allows, particularly everywhere where you have a chlorine, where you want to check chlorine if you do not have an online measurement. But this is the redox potential ORP, which is good to have there. And then finally, we had PhotoFlex Turb. You know it from last week eventually. So it's an IR light source, and it has all other rests we have set, including a completely drinking water reliable turbidity measurement, if you can measure with IR, with all advantages from AMCO clear standards and accuracy. So basically, that's why I call this meter here my Swiss Army knife, and it's still with this complete set, it is the most complete and flexible instrument which is in the colorimeter setting available. I skipped that a little bit because we are running out of time. So actually there's you cannot lose this vial holder, and you can use different cell sizes, which makes the measuring range, particularly in the low concentration, much bigger. It is also, as it is a field instrument, it has a very robust and undestroyable keypad and robust design. You can directly select 10 programs from a favorite list. Usually you would not have more than 10 test kits which you are taking. So actually you can work very fast, even if you do not have the right method at hand, and you can even choose this program in case you have forgotten the method number. We do not have barcode here unless in the lab option, because it is a meter with battery, it is in the field, it shall have a low power consumption. So you enter a program number to pull up the correct test kit program. And it is intuitive. You see everything at just one glance. So actually the measurement, you have the setting of a blank value if needed, you have the cell size, you have the measuring range. So everything is depicted on this graphical small display. It's a backlit display. Here it is just in detail. I will skip that because we talked about it. So as I say, it's robust and clearly structured. We do have different connections. So like here, the DIN ISO for pH and ORP sensors, all sensors which are available from our electrochemical side. And it's a power plug. And here, this is where you can connect to the station. We do have a RS232 pin cable, which then goes to RS232. So there is a USB adapter optional to connect it. And I just say, why and where would you take our Swiss Army knife? So service labs for portable and lab needs, environmental monitoring, because you do have this lab bench. Here we had the setting at a big fish farming and river monitoring. Then you have governmental surveillance and beverage aquaculture. Yeah, and this is what comes with this field set. It's the bench, as I mentioned. It has wires, it has a syringe, it has an electrode, beaker, and stand. For the pH electrode, there are calibration standards, tools, batteries, and finally also a little software PC software package for easy data handling with the required cable. And that's more or less finally look at the data output. So you see, from pulling data from the instrument to an instant storage and print, or if it's connected to PC, giving out the data to LIMS, to a multi-lab importer, cost-free, a little Excel plugin, which can be downloaded, and any other terminal program of yours. The data can be in any way given to for data management. This is a final overview. A little AQA is possible. That is also not typical for these class of instruments. So we offer a little meter check as we do for other AQA for spectrophotometers. And more information, there are videos available about the whole photometry. We do have flyers, we do have tips and tricks, and Analytic definitely will be happy to forward these tips and tricks also as a printed copy to you. And flyers are subject to updates, so Analytic will definitely be the one to hand out the latest version. And we are working on new versions this year, so there will be new material also coming up soon. I know that we are over the time, but I hope, dear Analytic, that we can have time for a little discussion and questions, if there is need.
Thank you, Susanne. I don't see any questions at this time. I do welcome anyone if they have any questions, comments that they would like to give us. So, thank you.
Thank you, Susan, Giovanna. Igual les recordamos que pueden dejar sus preguntas también en español. Sin problema las vamos a poder traducir. Si desean que abramos el micrófono también, nada más levanten la mano y le daremos apertura al micrófono. Y tal cual, las preguntas pueden ser en la sección de preguntas y respuestas o en el chat.
Maybe I also can have a little answer. Which is the fields where you are working? Some of you, many of you. Is it drinking water? Is it wastewater more? Or is there service labs and other, like mining? Mining is, we have customers from mining here, for example, in our region. So Jesus, eventually you can just add this. Is there more routine analysis, or is there also education and other industries?
It's both like environmental analysis and some people in industry.
Mhm.
Yes.
Yeah. So mainly, maybe this was really. I hope that we have that downloadable very soon.
Yes.
These DNA. So the DNA concentration measurement, was a new application to us, which was performed by a customer. And I want to encourage you all that really, since it is a universal instrument with a lot of routine analytical programs already in, but also to new, we will support Analytech for any question, for example, if there is really a user defined.
Yes, of course. Well, we have one question. We need more examples about the contamination water or wines qualities.
Okay. You will get this presentation, and in our manual, which is also available for download, and you probably will hand it out, Jesus, is that there is examples given which can be seen how it is working, because the wine industry, it is just a regulation. They have 2 or 3 parameters how they want to have color measured. So it's 3 wavelengths, the sum of 3 wavelengths, or it's 2 wavelengths. That is 1 for the color, and then they have also the ratio of 2 wavelengths, and this is the so-called color nuance. So actually, these application regulations are given in the markets, and these methods are programmed already. But there are others, like they also measure sulfate. So actually, and they have water testing. So the wine market, wine labs are very interesting to see, because they have a wide range of parameters, which in fact can be measured with the spectrophotometer, and it is a good market. Respectively, it is a good, if you are a service lab, for example, and you have wine customers, you can cover a lot of parameters from the water which is used for wine growing to the final product in the product quality, for example, color or so. Yes. And it can be found in the manual.
We have another question for Pedro Gonzalo. Is possible to make conductivity measurement in these instruments or in one different?
It would be an electrochemical instrument. This is coming up in a seminar soon, I know, in a webinar from yours, where this is a sensor which is connected, and there's also multi-parameter measurement, but the photometer does not support connectivity measurement.
Okay, I think so. No more questions. De igual forma, terminando el seminario, van a recibir un correo con constancia de asistencia. Ahí pueden también dar comentarios y dejar preguntas extra por si al momento no tienen alguna. Igual también se les compartirá información de la presentación y posterior de la grabación. Okay. I think so. No more question.
So muchísimas gracias por su atención. Y espero que ustedes sean contentas con esas informaciones y a Analytic, muchísimas gracias porque sea el partner para las preguntas que vendrán. Gracias a todos.
Thank you very much, Susan, Giovanna.
Thank you, Jesus and Luis, and thank you, Susanne. That was a very good presentation. Thank you.
Bye-bye. Thank you all.
Bye-bye.
Bye-bye.
Bye.
Bye.
Thank you.